Hello and welcome to Mathematical Coaching Center. Today in this video, we'll be discussing a theorem related to circles, and it is the part 2 of the video, and if you have not seen the first part, the link will be given in the description. But before we start, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further delay, let's begin. So let's first see the statement of the theorem. The statement of this theorem says that the line drawn to bisect the chord, which is not a diameter, from the center of the circle will be a perpendicular to the chord. So let us understand the statement of the theorem. So a line is being drawn to bisect the chord. So suppose there is a chord like this, okay, this is the chord, and there is a line which is being drawn to bisect the chord, and that should be from the center. Okay, so suppose this is the line. Okay, so now this line that bisects, suppose this is A and this is B. Okay, so this is AB, and the center, from the center O we are drawing a line that divides AB into two equal halves. Suppose this point of intersection is D, that means AD will be equal to DB. Okay, a line drawn to bisect the chord which is not a diameter, obviously this AB is not a diameter, from the center of the circle, okay, it is being drawn from center of the circle, will be perpendicular to the chord. That means this angle here will be 90 and this angle here will be 90. Okay, so this will be perpendicular to the chord. So these are the things that we must write in given. So in given, what we need to write is that AB is the chord, okay, AB is the chord of the circle with its center at O, which is not a diameter, and D is the midpoint of AB. So this point is the midpoint of AB, that is AD is equals to BD. And what is the thing required to prove? We need to prove that OD is perpendicular to AB. OD is perpendicular to AB. Okay, so these are the things we need to write in given, and this is the thing that we need to write in required to prove. Now we need to prove OD is perpendicular to AB. That means we need to prove that this angle here will be 90 and this angle here onto the side will be 90. So to prove this, what we will do is we'll construct two lines. Okay, so construction: OA, O comma A and O comma B are joined. So we'll join O and A and O and B. So this is how we'll join these two lines. So we have two triangles here. So the first triangle is ODA and the next triangle is ODB. So we have two triangles here. These two are the two triangles here, and with the help of these two triangles we'll try to prove the theorem. So let's proceed to the proof now. So now in triangle ODA and ODB, triangle ODA is this triangle here and ODB is this triangle here. So the first thing that we see is that AD is equals to DB. So this length here AD will be equal to DB. Why? Because it is already given that D is the midpoint, so AD will be equal to DB. Next is OA is equals to OB. Okay, the length OA, this length here, will be equal to OB. And why is that so? Because it is the radius of the circle. So OA is also the radius of the circle and OB is also the radius of the circle, so that must be equal. It is of the same circle, so it is equal. So OA is equals to OB. And the last line that we see is that OD is common to both. So we have three sides equal. So by side axiom, side axiom, we have ODA is congruent to ODB. Now if these two triangles are congruent, that means these two triangles are exactly same. This means that these two triangles are exactly same. So we have the angles that ODB will be equal to ODA, because we have ODA will be equal to ODB. ODA, this angle here, will be equal to ODB. And why is that so? Because they are corresponding angles. Okay, so this angle here ODA and ODB will be equal. So we now know that these two angles are equal because they are corresponding, means they are opposite to the equal sides. OB is equals to OA, so opposite to OA we have angle ODA, opposite to side OB we have angle ODB, so these two angles will also be equal. Now if we have that, what do we exactly get from this two angles being equal? So now what we will do is we'll try to add these two angles. Okay, so we are adding ODA, that is this angle here, and we'll add ODB, so this is this angle here. After adding these two angles, we see that this makes a straight angle here. That is a straight angle. See, so what is the measurement of the straight angle? It is 180 degree. So it is a straight angle. Now we know that ODA and ODB are equal. So what we can do is that we can write ODA in place of ODB because it is same. Now ODA plus ODA will give us 2 ODA, and now after cancelling 2 9 is 18, 2 0 is 0, so we have ODA is equals to 90 degree. So what is the measurement of ODA? It is 90 degree. Now we know that again, because ODA is equals to ODB, what we can say is that ODA is equals to ODB, and that is one right angle. Okay, so finally what we see is that the angle here ODA and ODB are 90 degree on both these sides. So what does it mean? It means that OD is perpendicular to AB. So hence proof. This is how we prove this theorem. Okay, so now conclusion. So what we can conclude from this? So if we have AD is equals to BD, suppose there is a line drawn from the center to the chord, and that line OD bisects the chord into two equal halves. That means AD will be equal to DB. Okay, at that time we can conclude by saying that OD will be perpendicular to AB. Okay, this is the result that we get from this theorem. And from the previous theorem, if this line drawn to the chord is perpendicular, if it is perpendicular, that means it is perpendicular, OD is perpendicular, that means it will, at that time AD will be equal to BD, that means D will be the midpoint. Suppose if it bisects, it will be perpendicular, and if it is perpendicular, it will always bisect. So this is the important result that we get from this two theorem. Okay, so in the next video what we will do is we will try to solve problems related to chords of a circle. We'll try to solve few problems using these two theorems. I hope that this video is helpful for you in understanding this theorem. So to stay updated with our uploads, please subscribe to the channel and turn on the notification bell. Thank you for watching and have a good day.